Hello everyone, it's Red Saber here from Saber C++, and today we're going to be learning about how to use a touchscreen display with Arduino. We'll be creating this drawing program where you can select different colors and draw with them. If you don't know how to wire this display up so that you can display text or change the background color, then check out my first video on this topic, which I've linked to in the description. Let's get started. Alright, so this is what we created in the last video, and if you haven't watched that, I'd recommend you check it out. It's the first link in the description. Alright, so this is what we set up. In the last video. It enables us to display things on our display, but it doesn't allow us to access the touchscreen. In order to read where the touchscreen is being pressed, we'll need to connect 4 more wires. First, I'll connect this red wire from the Y plus pin to A0. Then a wire from the X plus pin to pin 8 on the Arduino. Then a wire from the Y minus pin to pin 7 on the Arduino. And lastly, a wire from the X minus pin to port A1 on the Arduino. And now we'll be able to set up our program so we can tell where the screen is being touched. This is the program we created in the last video. At the top, we imported the necessary libraries, then declared a couple of constants to hold the values of the variable ports on the touchscreen, and then we created the touchscreen object, named it TFT, and initialized it with those 2 ports. In the setup function, we initialized the display using tft.begin, and we filled the entire background with black using this line here. Let's delete the rest of this and get started with our drawing program. First, we'll need to download a library that will allow us to control our touchscreen. Let's open up the library manager and type in touchscreen. We can select this first option here, which is a touchscreen library by Adafruit. We'll install that, and then here at the top, having installed that, we can include it in our sketch by typing #include touchscreen with a capital S .h. Now, we'll need to create a bunch of constants that will allow us to set up our touchscreen. First, we'll create 4 constants that will hold the values of the ports we just connected the wires to, so that we can determine where on the touchscreen it's being touched. So I'll define a value called YP for the positive Y pin to be A0, XM for the negative X pin to be A1, YM to be 7, and XP to be 8. Then we'll define the minimum and maximum values for our touchscreen's X and Y axes. Now the values that the touchscreen sends us won't actually be representative of which pixel on the screen we're touching. So we'll use these values to allow us to resize the values the touchscreen gives us to get pixel values for the screen. Then we'll define the minimum pressure necessary for the touchscreen to recognize it's being pressed and the maximum pressure allowed. And we'll also define the radius of the pen, which is the width of the lines that we'll be drawing on the screen. I'll set mine to 4, but we may have to adjust it later. When the touchscreen is being drawn on very quickly, it may miss some places where it's being touched, so if you widen the radius, then it'll create thicker lines, but it'll also mask any gaps in the touchscreen's detection. With all of this set up, we can finally create an object to represent our touchscreen, which will be of type touchscreen. We'll name it TS, and we'll initialize it using the XP, YP, XM, and YM ports we defined above, as well as the resistance of our touchscreen, which in this case is about 300. Now, in the loop function, the first thing to do is determine where the touchscreen is being pressed, which we can do by creating a variable of type tsPoint called P and setting it to ts.getPoint. This point has 3 values included in it, X and Y for the position on the screen, and Z for the amount of pressure. So if the touchscreen isn't being pressed, the pressure should be around 0, though it may be a little higher in some cases. So let's check if P.Z is less than the min pressure or greater than the max pressure. In either of these cases, we want to return so that we don't actually go on to the rest of the function. Now we can use the values we defined up here, defining the touchscreen's min and max on the X and Y axes, to actually resize the values we're getting from the touchscreen in this P variable. So we'll set P.x to be the mapping of P.x from the range of the minimum and maximum X on the screen to the range of the size of the screen, which will be from 0 to the tft.width. And we'll do the same thing on the y-axis with the minimum and maximum y, and the TFT's height. Now we can use the TFT.fillCircle function to fill a circle at the position of the P.x and P.y with the radius of the pen radius and a color of, let's do red. And there we go. Now we're able to draw a red line on our screen. Next, let's take a look at changing the colors of the line on the screen as well. Before we do, if this video has been helpful to you so far, please give it a like. To choose which color to draw with, I'm going to create a row of colored boxes at the top of the screen. Up by the pen radius constant, I'll define the box size to be 40. I'll also create an int called old color, which I'll just leave empty, and an int called current color, which I'll set to red. In the setup function, we'll draw a bunch of colored squares. First, I'll draw one using the tft.fillRect function, which creates a filled rectangle, starting at 0, 0, and extending for a size of box size in both dimensions. And this one will be red. Then I'll copy that line, but this time we'll be creating one starting at box size on the x-axis, so that it doesn't overlap with the other one, and we'll change the color to yellow. Then I'll create a green one. This one will start at box size times 2. Then I'll create a cyan one, a blue one, a magenta one, and a white one. In the loop function, we'll start by creating an if statement that will make sure that we don't draw over the color boxes that we use for color selection. So we'll check if p.y minus pen radius is greater than the box size to make sure that we only draw in the main area and not in the area where our color selection boxes are. Else, we'll change the current color to the color of the box that the user just touched. So the first thing we'll do is we'll set the old color to be the current color. Then we can check where the X value is to determine which box the user is touching. So if p.x is less than the box size, then we're in the first box, which means that the current color should become red. We'll also want to draw a white border around the red square so that we know that that is what's selected. We can draw an empty rectangle using the drawRect function. Once again, we'll pass in 0 and 0 as the coordinates, and it'll be box size in both dimensions. And the color will be set to white. Then we can create an else if statement that will check if p.x is less than box size times 2. And inside of this if statement, we'll be setting it to yellow, as that's the second color. So we'll set the current color to yellow, and we'll once again draw a white rectangle to border the yellow square, which starts at box size on the x-axis, but still 0 on the y-axis. Then we'll do the same thing for all of the rest of the colors. There was one slight difference, which is that I drew a red square around the white box when the white color is selected, because obviously a white square wouldn't show up on a white box. We also need to remove the white rectangle around the old color that it was around, so that we don't have two white rectangles. To do this, we first need to check if the old color does not equal the current color, which means that the color has changed, and we'll need to remove the old white square. So if the old color is equal to red, then we'll redraw the red rectangle using the fillRect function, once again, to cover up that white square. I'll do the same thing for all of the other colors. And there we go. Now we're redrawing the rectangle around the old color to cover up the white border. Let's upload our code and try it out. And there we go. Now we can select a color from one of these boxes and use it to draw on the screen. I'd recommend you try changing one or more of these colors to make sure you understand the entire program. Here's a hint. You'll need to change the color at one place in the setup function and 3 places in the loop function in order for it to work properly. You can also display images on these screens, so if you want to see that, let me know in the comments. If you'd like to learn about some other Arduino sensors and modules, check out my channel, Saber C++. Thanks for watching.